Okay, so now I've got some problems I need to figure out, and those problems are whether they're inconsistent with no solution, consistent with one solution, inconsistent with infinite solutions, or dependent with infinite solutions. So if they never touch, what are they?
No solution.
No solution. So would that be consistent, inconsistent, or dependent? Inconsistent. Okay. What if they touch but only once?
Consistent.
How many solutions? One. And so they are consistent. And what if they touch but all the time? Good. So how many solutions? Infinite and so again, that was a little kind of redundant, but I want to make sure that you knew that. So now we move on to the fun stuff. The fun stuff is, say, something like 2/3 negative x plus 2, and I don't know, 4x minus 3y is 12. We're going to use some of our old math to do some of our new math. Okay? First of all, do they touch? So are they one solution, no solution, infinite solution, and are they inconsistent, consistent, dependent? If they touch, where do they touch? Okay? All right. Oh, fun, fun, fun. So, what am I going to do? Well, this tells me at 1, 2, and then I go down 2, 1, 2, and I go right 3, 1, 2, 3. So I'm somewhere around here, and that's my line for the first equation. Intersect. Slope. This one tells me 0, negative 4, and 0, 3. And so I know those 2 points really quickly from my axis points. So I got 0, negative 4, so that's 0 in the x direction, negative 4 in the y. And 3, 0, 1, 2, 3. Okay. One really cool thing about this, I did not do this on purpose, I made this up. So how could I do it on purpose? But they intersect where? So do they intersect for 1? Yes. So they intersect. So therefore there's one solution. Which implies that they are consistent. And what does that mean? Where do they? Then where? Where? I'm terrible at this. Where? Where do they intersect? And then someone said at 3. At 3 what? X. There's an intersection at 3, 0. So in this case, I was able to draw it and find the intersection with my drawing. It didn't matter how cruddy my drawing was, and it was cruddy. Did you notice this was big and wide, and these are really narrow? This is so off base, but it doesn't matter because the slope went down to a specific point, and these 2 points were also on that specific point. So we were able to see that they both go through this point at 3 on the x-axis. So I know my intersection is on the x-axis at 3. Okay? So I answered the question using a graphic. So is it possible? Of course it is. Is it likely? No. Just because something's possible doesn't mean it's probable. Okay? We got lucky.